Hey everyone, welcome to this video around Azure in 60 minutes. And specifically my goal for this video is yes, introduce the core concepts and capabilities around Azure, but to help frame where those capabilities exist in relation to AWS. So as I go through the technologies, I'll try and point out, hey, the equivalent in AWS would be X. So if you already have AWS skills, it will kind of help you map them across. So let's kind of dive into this. And when I think about the first part of Azure, and one of the most critical pieces to get right is the identity. So Azure Active Directory is the identity provider for Azure. There are no other options. You are going to use Azure AD. If you're using Office 365, you are using Azure AD. Now, those identities are commonly replicated from Active Directory via something called Azure AD Connect. So that solution will take user objects, groups, and replicate them from Active Directory to Azure Active Directory. Now, you can filter down, for example, based on organizational unit, what objects to replicate. So you don't have to replicate the entire Active Directory. I can replicate multiple Active Directories into a single Azure AD, but AD is always the source of truth, i.e. I create the objects in AD and they then replicate to Azure AD. I don't replicate objects from Azure AD to AD. Now there are integrations with, for example, HR systems, provisioning solutions, and they appear to replicate to Azure AD, for example, Workday. But the reality is when you add those solutions, they actually talk to a special component of Azure AD Connect. It still creates the object in AD first, and then it replicates to Azure AD. So Azure AD, this is the identity store for the Microsoft clouds. Now, Azure AD speaks a number of cloud protocols. I'm just building out the replication flow. So Azure AD speaks things like OAuth 2, OpenID Connect, SAML, whereas Active Directory speaks kind of on-premises protocols, Kerberos, NTLM. And so Azure AD can be used far beyond just, hey, I'm going to use it for Azure or Office 365. If you think about all of the other SaaS solutions out there on the internet that you might want to federate with, I can use Azure AD as a federation broker, i.e. I get my AD to replicate to Azure AD, I get single or seamless sign-on between my on-prem devices on my corporate network and Azure AD, so I don't really even know there's a separate identity in Azure AD, and then I can federate Azure AD with those other SaaS solutions. So if I was to jump over quickly to the portal, I'm actually going to go and look at my Azure Active Directory. I can see I've got various users. Now most of them, the source is going to be Windows Server AD. You can create native cloud accounts. So the source would be Azure Active Directory. I can also add guests. So when I have those guests, they can come in through a number of different means. Here you can see, for example, I've got a Yahoo account. That's using OTP, a one-time passcode. Here I've got a Google federation. So it's a guest from Google. Here I've got a guest as a Microsoft account. So I have these different capabilities to integrate in. And so B2B is a huge capability. If I have partners I want to collaborate with, we can invite their Azure AD accounts, their Microsoft accounts, their Gmail accounts. There's a lot of different options for getting those integrated in together. So here I've got my Azure Active Directory. And if I actually step out for a second and I go to my enterprise apps, this is where I can add the applications that I want to federate with. So I've got some added in my environment. If I do new application, 3,216 applications like Box, Concur, G Suite, Dropbox for Business, DocuSign, GitHub, Oracle, Salesforce, ServiceNow, Workday, and they're just some of them. Obviously, there's a lot more. So if I'm using those other kind of SaaS solutions, I can seamlessly single sign on to those as well. So that's kind of a nice capability of Azure Active Directory. Now, in addition to that, there are a number of key features we commonly use. Multi-factor authentication, conditional access. So the conditional access is used by pretty much every organization. And it really ties in nicely to technologies like MFA. I don't want to just turn MFA on. If I'm constantly prompting someone for MFA, they just get muscle memory and they just accept. Azure AD MFA really uses your phone. It can text you, it can call you, there's an authenticator app. But if I prompt someone for MFA all the time, they're just going to always accept it. And I really lose the benefit. Conditional access lets me say, well, for these circumstances, maybe it's location, although we're trying to move away from that with kind of zero trust networking. Maybe it's the app I'm accessing. Maybe it's the device I'm accessing it from. Maybe I'm taking risk into consideration. Then I need to meet certain criteria, and one of them can be MFA. Identity protection is that ability to determine risk. There are ways that utilize things like impossible travel after a learning period to work out, well, maybe that's a VPN, so it's actually not an alert situation. Maybe my credentials have leaked on the dark web. That's monitored as part of identity protection. Maybe it's detecting anomalous behavior. Maybe it's using machine learning to say, that's not my typical behavior. So identity is really a key part of my protection now. I mentioned B2B, inviting guests to collaborate. And then things like privileged identity management, I have to elevate up to do certain roles to access certain types of objects, access reviews based on application access, group membership roles. And I can do those myself, I can delegate it, or I can do self-service reviews. Ask people to say, hey, do you still need this? Terms of use. You need to agree to this before you can use this application, use this service. So the identity is really that cornerstone, that first thing we need to get in place. Now it has to be Azure AD. The actual authentication, the preferred option is to use cloud authentication, i.e. we're replicating a hash of the hash stored in AD, so it's not the original hash. It's a hash of the hash, it can't be reversed, goes through 1,000 iterations of SHA, it's salted, it's secure. And then we're really getting the cloud scale authentication. If I really want my on-prem involved, there's also a pass-through authentication option, which will check against my on-prem domain controllers. Or I can use federation. That's really being de-emphasized today. It doesn't really gain me very much, and it's just a lot of infrastructure to maintain. Let's think of structure. So the identity is in place. I have my Azure AD. I'm going to create subscriptions. So subscriptions, this will be the equivalent of something like an AWS account. And when I talked about kind of my Azure AD, that fits into the identity and access management piece of AWS. So I'm going to create subscriptions, which is where I can place resources. Now, before I do that, I create resource groups. And within a resource group, I have multiple resource groups, I place resources. Every single resource must live in one and only one resource group. I cannot nest them. So a resource group is designed to think about these things in the same resource group share a common life cycle. I'm going to create them together, they're going to run together, they're going to ultimately get decommissioned together. And the reason we want to put them together is because there's other things we can do at the resource group level, like role-based access control. Now, I do create the resource group in a region. That's just because there is metadata. There may be regulatory requirements around where I create things, but the resources I create in that resource group are not bound to that region. I.e. the resource group could be East US, but I could have things in the resource group in East US, West US, Europe, whatever I wanted to do. So I'm going to create a subscription, which is the equivalent of an AWS account. I'm going to create resource groups to organize my resources. And now I've actually got things running in Azure. Now there is another layer. Well, actually, it's a whole hierarchy. We can use management groups. In an AWS, you would think of this as AWS organizations. When I turn these on, I get a root management group. So that sits directly under my Azure AD tenant. When I activate this, every single subscription that is using my Azure AD will be tied and fall under that root management group. Now, what I can then do, I can create a whole hierarchy up to 6 levels deep of management groups where I can organize my various subscriptions. Now, we do this for a number of reasons. I can assign policy. I can assign role-based access control. I can assign cost management. And policy becomes really important when we look at things like DevOps, where we're going to leverage build pipelines and release pipelines and just automatically have resources created. I'm losing the idea of that IT operator person sitting between the developer and the resources and checking it. That doesn't work. In the cloud, I don't want to sacrifice agility and speed for control, but we still need to make sure we're creating things the right way that are still falling within whatever policies we require. So Azure policy is enforced at the actual fabric level. So if I create a policy, if I create a resource through the portal, through PowerShell, through CLI, through a template, doesn't matter what, it has to pass and check that policy. That policy could restrict the regions. It could restrict the type of storage account, the replication I need, agents must be installed. There's a whole suite of these things. Who can have a public IP address, maybe only in a special DMZ subnet. Role-based access control is super granular, what operations you can perform on what types of object at a certain scope. And then cost management, I can track costs, I can create budgets based on dollar cost, based on metrics like CPU cores leveraged. And all of these things can be applied at the root management group, at child management groups, at subscriptions and resource groups. So you could think about, I would apply fairly broad core scaffolding at the root management group and higher up management groups. I don't want to be too specific. As I get closer to resources, I would start getting more specific. For example, in a development management group maybe, or development subscription, or maybe development resource group, depending on how I organize things. I might restrict really expensive virtual machines. Whereas in the production, I might block non-geo-replicated storage accounts. I might ensure log analytics is configured where I'm going to store all my logs to. And if we have a quick look, just to give you an idea behind this, if I just search for policy, there are a whole bunch of them built in. Again, I can assign them at all of those different levels. So if I was just to search, let's say, if I search for network, you can see all these different options. And what I'll actually do is I'll change this for a second. Let's search for public IP. So here you can see there's a built-in one, should not have public IP addresses. This would just block public IP addresses. There's actually other ones I can get. So if I add a new policy definition, I can import from GitHub. And in GitHub, there's a whole bunch of samples. And if we go and look under network, there are actually ones about no public IP except for one subnet. So here, this would actually enable me to define essentially a DMZ subnet, and only that subnet can have VMs with public IP addresses in. So that's kind of super useful. Now I mentioned creating resources. Everything in Azure behind the scenes is JSON. I can provision via the portal, via the CLI, via PowerShell. The best way is a JSON template. They're prescriptive. They're declarative. I'm saying my intent, what I want the end state to be. I'm not telling it how to do it. And because it's declarative, it's idempotent. I can rerun this template as many times as I want. If it matches what's deployed in the resource group, nothing is done. If the state of the resource group does not match my template, it will make it so. There is a large library of samples, and the JSON is actually shown via the portal for many types of operations. So if I jump over quickly, let's just look at something. So if I just look at a virtual network, super basic, you'll notice I have export template. Here it will actually show me a template of that resource. And Azure is basically made up of resource providers. Here, I can see the resource provider is Microsoft.network. And within the resource provider, there's a resource of type virtual networks. So it's creating an instance of that type. And then there are various parameters. And when I use the templates, the parameters are actually separated into a different file. And that's useful because if I have multiple environments, multiple instances, I don't want to edit the template. I want the template in a source control so it can cleanly move between environments. I just tweak the parameters based on the environment or instance. Here's another example. This is a clean template and there's a whole library on GitHub. But here I've got parameters around storage account type and a location. And once again, this time the resource provider is Microsoft.storage. It's of type storage accounts. There are some parameters around the SKU to use, the kind of storage account, and once again, a separate parameter file telling me the type of storage account. So really easy to leverage. It looks a little bit verbose. On first glance, if you've never seen templates, you'll be like, this looks scary. But it's really just very distributed, spread out, lots of spacing. But it's pretty easy to understand. There's core sections. I have parameters, things I'm telling it. I have variables, values I want to define and use throughout the template. And then the actual resources I actually want to create. Now I don't have to use ARM templates. You can leverage other technologies, things like Terraform. If I have existing investments in a certain technology, I can carry on using that. Actually, Terraform is a great partner. They actually have team members working with the Azure group. They have an Azure resource provider. And then I can use one technology for Azure, for on-prem, for other clouds. And just to build on templates and creating things, we have something called blueprints. And blueprints bring together a number of different types of artifact. Their goal is to stamp out a certain configuration. For example, here I've got kind of core governance blueprint I've created. And what I can do with a blueprint is I can assign policy, I can assign RBAC, and I can deploy templates. And as part of that, I can also create resource groups. So here you can see I've got blueprint, and I can say, well, assign this policy, which is setting a tag. Tags are key value pairs that we can assign. I'm going to create a resource group called RG Networking. I'm going to assign my network admins group contributor rights. Then I'm going to deploy an ARM template, which creates a core network. When I deploy this, and as part of my configuration, I can choose certain options for how it's actually applied. For example, I could say, well, this is deployed, this artifact, and you cannot change it. So if I look at my core network, I've got my template here, got my location, all the information about it. And essentially, as part of my configuration here, I can't change this. And where I actually define that is, if I come out this for a second, when I assign the blueprint, once again, blueprints, I can assign at the subscription level. When I assign it, I have a lock option. So if I say read only, any of those resources that I'm applying cannot be changed. That core network, you couldn't add a new subnet to it. Or I can say, well, just they can't delete it. So they can modify it, but they can't remove it, or don't lock. I'm going to apply an initial state, then do as you wish. So blueprints are super useful as a governance option. I can then apply this, for example, to any new subscription that gets rolled out. If I have a DevOps, they can pull this in and leverage it. And if I was thinking about templates and these types of technologies in an AWS world, I'd probably be thinking about CloudFormation. But of course, AWS, it could use things like Terraform as well. The next thing to think about would be resiliency. I've got my identity worked out. I've got my governance in place through my policies, my RBAC, my cost management, maybe using blueprints. I've worked out my provisioning. Now I need to make sure it's resilient. Now, Azure has a whole number of regions spread out throughout the world. And for disaster recovery, you want to make sure you're deploying to a minimum of 2 regions. So if I go and look at the current map of regions, I can see there's a whole bunch in the US and Europe and Asia and Australia, and you can pretty much use any of them. There are a few regions that are geofenced that are part of separate clouds. For example, China has its own cloud. There is a Germany-specific cloud because of its data sovereignty regulations. There is a US government cloud. But they're just a few of the regions. Pretty much everywhere else is just part of the Azure Commercial Cloud, so you can just use them. Now, we do pair regions. Our pairing is for certain internal services. If I did a geo-replicated storage account, it will always pair between 2 specific regions. As part of that pairing, when updates are rolled out, they're very careful to not apply the same update at the same time to paired regions, because if that caused a problem, it wouldn't impact its paired region as well. So I want to make sure I'm always using at least 2 regions for true disaster recovery. Now those regions, as I said, are paired. Within a region, I should still have multiple instances of my workload. I can use availability sets or availability zones. And don't forget, we need both. I need disaster recovery and I need high availability. Within a region, I'm really thinking high availability. I want resiliency from patching, from node problems, from rack problems, maybe even a data center problem. Then I think DR, some region level outage. So we have a region. And a region is defined as a 2 millisecond latency envelope. That region is typically made up of multiple physical data centers, different structures. And some of the regions, and this is being built out, have a concept called availability zone. This is where those separate facilities have independent cooling and power and communications. So within a certain subscription, I might see an AZ1, AZ2, and AZ3. And I would make sure I deploy my workload on separate zones. So I have one web server on AZ1, one on AZ2, one on AZ3. That would give me some additional resiliency. Now, these are logical, and they're logical per subscription. So if I had a second subscription, AZ1 in sub 1 would not equal AZ1 in sub 2. They're just guaranteed to be separate availability zones within a subscription. So they don't work cross subscription. Another option is availability sets. So an availability zone is made up of multiple clusters. A cluster is a whole group of racks that are managed by a common controller. Availability sets enable me to define an availability set, and that will be distributed over 3 fault domains. A fault domain can be thought of as a rack. A rack has a switch, it has a power supply, it could fail. With an availability set, I simply deploy resources to it, and Azure will take care of distributing them among the 3 fault domains. I cannot use availability zones and availability sets for the same workload. I really kind of pick which one I want to leverage. If I use availability sets, I can take a hit of an entire rack going down. But if the entire data center goes down, I've lost my workload. If I use availability zones, then I can take an entire data center going down. But if something happens to the whole region, like a flood, I've lost my workload. This is why we think we want HA and we want DR. So let's think about networking. Virtual networks are created within a region, within a subscription. In AWS, you'll be thinking about a virtual private cloud, a VPC. So a virtual network exists within a region. It cannot span regions. It cannot span subscriptions. So if I had multiple regions I'm leveraging, I'd need a different virtual network in each one. They're made up of multiple IP spaces. So it's not just one contiguous IP space. I could assign it a 172.16, 10 dot something. I can have multiple IP spaces, CIDR ranges within a single virtual network. And then I break that up into virtual subnets. A virtual subnet is not bound to an availability zone. A virtual subnet spans the entire region, as does the virtual network. Now, I can connect virtual networks together. Network peering is the preferred option. This is where on the Azure backbone, I'm saying, look, connect this network to this network. They can be in the same region or different regions. There are ingress-egress charges going out of the VNet and into the VNet, but it's going to give you the best performance, lowest latency. I could connect using a VPN gateway. If I have ExpressRoute, that's like direct connect for AWS. If I connect multiple virtual networks to the same ExpressRoute circuit, they are then connected to each other. However, that connection is hairpinned at the Meet Me location. So if my Azure region was in East US and my peering point, just for example, was Dallas, then those two virtual networks in East US would actually bounce the traffic via Dallas. So you can think about the latency that would introduce. And we can run both IPv4 and IPv6 in a virtual network. Now, typically, only egress traffic from a region is charged. There's no ingress charges. I pay for traffic leaving a region. If I want a public-facing service, I don't have to do any kind of special subnet or service. I use a public IP address. Yes, I can assign this directly to a service, like a VM, but typically we're going to use some kind of load balancer or some kind of application gateway. When I have multiple regions, I want to balance traffic between the regions. So here I can think about Azure Traffic Manager, which is DNS based. So that would be like AWS Route 53. Or I could use Azure Front Door if it's HTTP based. That would be like AWS Global Accelerator. So there's different geo-balancing capabilities on the networking. And from a security perspective, there are network security groups. That enables me to define policies to say, well, this type of traffic can go between these networks. Huge amounts of detail can be leveraged. And I can apply that at a virtual subnet level. Then we have data and storage. Azure has a lot of different data services. They come from just blobs all the way through to relational databases. Now, storage accounts provide a number of key storage services on which some of the other higher level ones are actually built on top of. So there is blob. This would be like AWS S3, the simple storage services. And I have block blobs, page blob, appends blobs. There are queue services. There are tables. There are file services, which provides an SMB3 based file service. So the Azure files will be similar to the AWS Elastic file system. And with those storage accounts, we have different types of replication. I can just have 3 copies within a region. There's always at least 3. There's no option where there isn't 3. So locally redundant, there's 3 copies within the region. Or I can do zone redundant, where there's actually 3 copies within the region, but they're spread over availability zones. There's geo redundant, where I have 3 copies in one region, 3 copies in the paired region. There's zone globally redundant, where I have 3 spread over availability zones. Then it's replicated where there's 3 copies. And there are options around read access to that geo-replica. There are different performance tiers. There's standard and premium. Premium has higher throughput, higher IOPS. There are different access tiers like hot, cool, and archive. So you could think about cool would be the AWS S3 infrequent access. Archive would be the AWS S3 Glacier. Here I'm looking at a storage account. You can see I've got a number of different images. One's in the hot tier, one's in the cool, one's in the archive. So I can manually move them between the different tiers, or there's actual lifecycle capabilities as well, based on not being modified for a certain amount of time. Hey, let's move it from hot to cool. Hey, not been accessed for a longer amount of time. Let's move it to archive. So there are life cycles, so I'm not manually having to move the things. Realize archive really is archive. When I want to bring it back, it's going to take a little bit of time. I cannot directly access archive. I have to move it out of archive into cool or hot to actually get to the data. When I think about, I say virtual machines, but I can actually use these for other types of workload, the container services, things like Azure Kubernetes service. I can actually attach disks to my containers for that persistent storage. But VMs, containers, they can use managed disks. Behind the scenes, they're using page blobs, but the storage account is abstracted away. I don't have to worry about storage account limits or managing it. I just get a disk object. Those managed disks, again, come in different sizes. They come in different performance SKUs. There's standard hard disk drive based, there's standard SSD based, premium SSD based, and then ultra SSD. Ultra SSD is really cool in that I have 3 pivots. When I create my ultra SSD, I specify a size, an IOPS, and a throughput. And I can actually change those as my needs are modified. So hey, I'm about to do some really big job. Let's up the IOPS. Okay, that's finished. I'll lower them again so I can optimize my spend. Just like AWS, it's consumption based for everything in Azure. I pay for what I'm using. I pay for the seconds a VM is running. I pay for the seconds a container's running. I pay for the amount of storage I'm leveraging in my block blobs, for example. So disks have a certain set of capability. If I look at the pricing page, here I can see details about the premium SSD. Based on the size, I get a certain number of IOPS and a certain amount of throughput. If I look at the standard, so that was the premium. If I look at the standard, again, based on the size, I get a certain number of IOPS, a certain amount of throughput. Standard HDD, size, IOPS, throughput, it's all fixed. Ultra, well, now we have kind of these increments of what I can do. There are basic mappings up to 1 gigabyte, but then once I get to my 1 gigabyte, I can go all the way up to 64 terabytes. But notice here, all these other ones said IOPS per disk, throughput per disk. When it's ultra, it's IOPS range, throughput range. So I pick where in these numbers, and this is the maximum it can go to, I want it to be. So with an ultra SSD, if you look at this, I could potentially create a 512 gigabyte disk that can do 160,000 IOPS. Or I can scale that down as I want it to. A key point though, if I look at the sizes of VMs, I'll look at the Linux ones, for example. There are different types of focus and speciality for different VM SKUs. I'm just going to look at memory optimized. The point is, and what I'm going to focus on here, is there are data settings based on the disks as well. So there's a max number of data disks supported, then there's actually a maxed amount of throughput in terms of IOPS and megabits per second. So we just need to be aware of that, because it's no good just attaching a whole bunch of disks to a VM that have got super high IOPS if you've picked a VM SKU that doesn't support that number. So when we're thinking about our storage throughput and performance, I have to consider the disk, and I consider what is the actual compute resource capable of as well. So I balance those two things together. Now, the basic storage services in an Azure storage account give me a lot of capability. Then there are more advanced services. There are things like relational databases. There are various SKUs around this. Think about Azure SQL Database, that's SQL Server running as a managed service. There are versions where I have a dedicated amount of resource per database. There are ones where I have an elastic pool of resource that is shared among multiple databases. There's a version that gives me great compatibility with on-prem SQL Server where I have this managed instance deployed into my virtual network. So there's no shared components with other tenants. It's all in my virtual network. And again, I can create managed databases within that service that will share a certain amount of resource. There are serverless options. There are hyperscale options. And then outside of relational, there are NoSQL solutions. Things like Cosmos DB. This is a multi-master solution. I can have replicas all over the world. I can have a replica in every Azure region if I wanted. And I pick the consistency. So I can have strong consistency. That would be very similar then to a single master essentially. Or I can think about different levels of maybe session level consistency or eventually consistent, where I can write to every copy, and depending on my configuration, that will drive that read-write consistency within a certain scope. So Cosmos DB is kind of that premium managed offering, but there are many others. I can use things just like NoSQL, Postgres. And there are other more advanced data services like HD Insight, Data Factory, Databricks for analytics and kind of more data manipulation. And then finally, compute. And I'm going to break this really into 3 different levels. I'm going to start with virtual machines. Now, virtual machines are available in different SKUs. So when I say VMs, this is really AWS EC2, the Elastic Cloud Compute. There are SKUs that have different ratios. Some are memory optimized. They have more memory ratio than CPU. There are compute optimized. They have more compute than memory from a ratio perspective. There are ones that are storage optimized. High IOPS maybe have very fast temporary cache storage available. There are specialist SKUs that might have NVIDIA CUDA cards, high performance compute, 40 gigabit RDMA network connections between them. There's a whole number of different options that I can leverage. And within those SKUs, there are different sizes. So once again, if I jump over, I can see here there's different series. And we talked about kind of those compute optimized, memory optimized, storage optimized, various types of accelerated compute. Those NVIDIA CUDA cards, they can be used for visualization, AI training, compute intensive workloads. And then even within these, if I go and pick one, there are different sizes that relate to number of CPUs, memory, temporary storage, persistent data disks supported, and then those throughputs, and then network bandwidth throughputs as well. The B series is really interesting. With the normal virtual machines, I get a certain number of virtual CPUs, and I am basically paying for 100% of that virtual CPU. The B series is burstable. I get a certain portion of a virtual CPU, but if I don't use all of it, I can start to accrue credit. So here you can see with just one virtual CPU, ordinarily I get 10% of that base performance. I can burst up to 100% if I accrue credit. So think of it like a cell phone plan. I get so many talk minutes a day. If I don't use my 100 talk minutes that day, if I only use 50, I can carry 50 over to the next day. And I can keep accruing more and more until maybe by the end of the month, I have 5,000 talk minutes left. And I could talk forever. Same here. Except you can't accrue an infinite number. There's a maximum amount I can accrue based on the size. But if my VM was not running at 10%, it was running at 5%, I would start to accrue credits. And then it would allow me to burst to 100% for a certain amount of time until I exhaust the credits and I'll drop back to my base CPU performance. If you think of a lot of workloads, they have those kind of Storm domain controllers. They have that logon Storm. So Burstable might be fantastic for those. They're pretty quiet most of the day, but they get really busy at 8:30 a.m. So these burstables let me pay less, I can accrue credit and then burst as I actually need it. The point is, I need to understand my workload. Once I understand my workload, I can pick the SKU and the size based on what I need. I can change it. I can just reboot the VM to get a new size. There's actually technologies like Azure Advisor. So there are services in Azure to help me actually get a baseline of what I'm using today. Azure Migrate helps me look at existing workloads, will tell me its current size. It can monitor the performance and tell me what it should be. But even after I've moved it to Azure, there are actually services that will look at what I've actually got deployed and will give me guidance across high availability, security, performance, and cost, and would say, hey, look, we think you should actually right-size this a bit more. You're running at this size. It really doesn't need to be at this size. You can shrink it down. So there's help when I'm thinking of moving. After I've moved, there's help to tell me, hey, look, let's resize this thing. We can save you some money. We can shrink this thing down. Or, hey, we're hitting limits. We think we should increase this thing. So there's kind of this constant feedback I'm going to get. I don't have to create my own images. I can absolutely bring images to Azure. There are services like Azure VM Image Builder to help me build Linux and Windows images in Azure. The marketplace has a huge number of images for both Windows and Linux. They have base OS, they have pre-built applications, they have virtual appliances. These are all VMs. What about if I have a 20 node web file? I don't want to create 20 VMs. I want to maybe turn them on and off based on my load. In the cloud, I pay for consumption. I pay per second. And so I don't want 10 running if at a quiet time I only need 3. Now I could manually write something, or there is auto scaling. So based on metrics, based on schedules, metric could be CPU average, could be a queue depth. Schedule could be at this time, or for a Friday night, I'm a pizza restaurant, I'm about to get really busy. Let's rank up the number of instances. So VM scale sets let me pick a gold template. Azure will take care of replicating it. I can give it those minimum and maximum numbers. I can give it criteria of when to scale up, when to scale down. It will integrate with the Azure Load Balancer to distribute the traffic among the instances, and it will do all of that for me. So that's like the AWS auto scaling capability. Beyond virtual machines, containers. It's obviously an exciting time right now. A large number of the Azure services are actually built on containers. Now, the core basic service, I could just run containers in a VM. I could create a VM, I could install Docker, and I could just run containers. But there are a number of different container services available. So I don't have to just do that bare basic. I want orchestration. I might not want to worry about installing Dockers on these various container hosts. So the biggest service is going to be the Azure Kubernetes Service, AKS. This is a managed Kubernetes service. It can utilize its own worker nodes, i.e. I'll actually have VMs created in my subscription that I can see. That will be the worker nodes. That's where it's going to actually run the various containers or pods that it actually creates. There's also Azure Container Instances. This is container as a service. I don't see the container hosts. There's just this kind of infinite scale kubelet that will be available to the AKS, or I can deploy to ACI directly that I can leverage. So ACI would be like the EC2 container service. Fargate. The Azure Kubernetes Service, AKS, would be like the Elastic Container Service for Kubernetes, EKS. And it is Kubernetes. At the end of the day, it's portable. I can run this on-prem, I can run it in Azure, I can run it anywhere I want. That's one of the great things about containers and Kubernetes. There are basic and advanced networking options. Advanced lets me integrate with existing virtual networks. I have far more control. Basic really is just going to do its own thing and then NAT the traffic across. For persistent storage, we're going to use the Azure disk that I talked about earlier. There are options around Azure files as well, but it's more common to use Azure disk. And it fully integrates with CI/CD. So if I'm doing DevOps, if I have continuous integration, continuous deployment, delivery, I have my build and release pipelines, I can hook into this very deeply with DevOps. Uses Helm very nicely, Helm charts from actual apps, and it's pretty easy to get going. I can leverage things like the Docker Container Hub. I can use the Azure Container Registry. So I can have Azure-based image storage, and I can even set that up to automatically replicate across various regions so I can have those images close to where I actually want them. So there's a lot of rich container services available. Most of the time you're going to use AKS with worker nodes. Maybe you'd use the ACI to burst to. So hey, I've got this fixed amount of container host available, but I can burst to ACI if I need to. I've got some exceptional unplanned workload. And then we get to the PAAS services. There are a lot of different PAAS services in Azure, targeted at different types of application workload. There's the Azure App Service. This is really focused around web-based applications. It could be a web app, it could be a mobile app, it could be an API app, but it's doing things around HTTP. The regular Azure App Service is designed around a multi-tenant backend. You're isolated from your perspective, but there are shared components. There's also dedicated options where it's deployed into your virtual network. From an AWS perspective, this will be very similar to something like AWS Elastic Beanstalk. There's Azure Functions. This gives me serverless compute across a large number of languages. C#, Java, Python, many more. This would be Lambda on AWS. There are things like Azure Logic Apps. So if I think about various integration solutions, various flows, I'm getting triggered from something, I want to go to another system, maybe write something out, Logic Apps provides a visual canvas to kind of drag and drop different components to create those flows. There are things like Service Fabric, on which again a number of Azure services is built. This gives me a very resilient actor model where I can have these components running, performing logic that will kind of self-heal. So lots of different options. There are many more. Beyond like these PAAS, there are machine learning capabilities, cognitive services, more advanced data services, Internet of Things. There are Azure services that run on-prem. Azure Stack brings Azure to on-premises. Azure Databox Edge lets me integrate with storage services and actually brings some of those sort of cognitive services to an edge device. It actually has specialist hardware in the Databox Edge, the Brainwave card, the FPGA. So I can do things like cognitive service on Databox Edge. So yes, it helps get storage moved to Azure, but I can actually do edge compute. I could maybe manipulate the data before sending it or just use it as an edge device. And because it is running the IoT Edge, it can run various containers. So I said kind of around Azure in 60 minutes. I think this is about 50 minutes, so I was a little bit quick. I hope this helps. It's designed to just get some of those basic things to think about. What are some of the basic services? And try and help think about, hey, look, I know AWS, how that might map across. Thanks for watching.